In this video we're going to continue going over the problems from the Unit 2 Concepts worksheet. So in this video we're going to focus on problems 6, 7, and 8 on the next page. So the first one, which of the following is the correctly simplified form of the expression below? 9ab to the fourth power, all of that is in parentheses and then raised to the third power right here. So the way that we interpret this, if you circled any of these first three answers, you made a mistake. These are all incorrect, and they all have the same issue with them. It's this 9 right here. We should have gotten a 729, and all of these have 729. Here's why. So we are looking at 9ab to the fourth, and that's raised to the third power. Now there are a couple ways I could go about showing this, but here's basically what I do, and then I'm going to show you the expanded form for why this is. So this is going to be 9 raised to the third power. What we're doing is we're raising all of these factors to the third power. Everything on the inside that's being multiplied, we're raising that to the third power. And this only works with multiplication and division. If we have any addition or subtraction, we need to be really careful, because most of the time we won't be able to do something like this. This is 9 to the third power, a to the third power. Remember that it's understood that there's a 1 right here. There's an implied 1 when there's nothing else written. And this is b to the fourth power, and then raised to the third power. So each individual factor is being raised to the third power, including number quantities. So a lot of times we forget that 9 and a and b are all numbers. They're just numbers. This a just stands for an unknown quantity. Same thing with this b. These are different, possibly different, unknown quantities. This is a quantity right here. We treat them all the same way. A and b are just numbers, just like anything else. We can cube them, we can square them, we can do all sorts of different things with them, just like we can do numbers. Any other numbers, like 9 for example. So when we raise 9 to the third power, we get 729. So that's the first part of it. Here's why this works. So I'm going to go back up here, and I'm going to explain where this is all coming from. So let me just start over actually. Here's 9a, b to the fourth power, and then all of that is raised to the third power. What I'm going to do is I'm going to write this out as a partially expanded form of this expression. So I'm taking this, everything that I'm underlining here in blue, I'm going to raise to the third power, or I'm multiplying it by itself 2 other times. So 9ab fourth, and then 9ab to the fourth. Now, using the associative property, I know that these parentheses don't matter. Using the associative and commutative properties, what I can do is I can write all of the 9s up front. This is all multiplication. I can put multiplication signs in here if I really want to. They're not necessary, but I can. So this means that I'm just multiplying all these things together. I can rearrange them however I want because of the associative property and because of the commutative properties. Oops. A times b to the fourth times b to the fourth times b to the fourth. Okay. Now this is 9 to the third power, a to the third power, and b to the fourth power. And again, these are all multiplied by each other. So this, jumping from here down to here, using this idea of distribution, the distributive property, that's basically what we're doing here. We're skipping 2 steps, and we're skipping a whole bunch of properties, and we're just cutting to, it's just a shortcut. We're just cutting the fat out. So we don't have to do any of this stuff. We can just jump down here. So when we have 729 from 9 to the third power, we also have this a to the third power. So this a, again, had an implied 1 in the exponent. and we multiply exponents. If we're raising a power to a power, we multiply exponents. 3 times 1 is 3. That means that e is out. We have a to the implied first power here. We're kind of ignoring the fact that we should have raised it to the third power as well. And then we should also have b, not to the 7th power, but to the 12th power. And the reason for that is whenever we have a to the n power, and then raised to the m power, that's going to be a to the m n times m. We just multiply the exponents. So if we're multiplying the exponents, that's going to be 12. If you added the exponents, you're confusing it with this other property, the a to the n power, a to the n power times a to the m power. That's going to give us a to the n plus m. These are visually different from each other. They look kind of similar, but they're visually different because here we have a number to a base, and here we have that same base with a different exponent, or possibly the same exponent. It works the same way, but the fact is we have the same base right here, and we keep the same base. In this other one, a is the base on this n exponent, but on the m exponent, we have this entire thing as the base. Everything in this set of parentheses is the base. So basically we have one base to start out with, and we raise it to a power and then raise it to another power. Basically we're starting with one number, we end up with one number. Here we're starting with two of the same, and then we're ending up with the same thing. So this one, way back up here, this 9ab to the 4th power, this b right here is being raised to the 4th power, and then that is being raised to the 3rd power, which means we multiply those exponents. So our answer should not be d either, it should be f. F is the only answer that makes sense. Okay, we're going to simplify the expression below, number 7. Let me erase the rest of this just so it doesn't get in the way. We have 2w to the 3rd power, x to the 4th power, y to the negative 2nd power, z to the negative 8th, and then we have on the bottom 6w x to the 4th power, y to the 2nd power, z to the 12th power. And this looks really complicated at first, and what sometimes happens is people tend to shut down when they see something like this. But just take it one step at a time. I'm going to rewrite it over here so that way I can mark it up without interfering with my original problem. 2w to the 3rd power, x to the 4th power, y to the negative 2nd, and z to the negative 8th. Now this is clearly not going to be, this is not simplified right here because we have x's and w's and all that on top and the bottom. So what we want to do is use the rules of exponents to help us eliminate some of these things so it's less confusing. What we tend to forget is that this bar not only means division, but it also means it's a fraction bar. We can think of it both ways at different points to make it more helpful to us. Now, if we had let me do it over here. If we just had 2 over 6, we could reduce that to 1 over 3. So let me write that. Let me write my long fraction bar. I'm going to have a long fraction bar. And I can reduce this to 1 over 3. I can divide the top by 2, I can divide the bottom by 2, and I get 1 over 3. That doesn't affect anything. Okay, this is w to the 3rd power, and I have a w on the bottom. So what a lot of people say is, oh, it's a w to the 3rd power minus 0 would give us w to the 3rd power. That's not true. That's not true, because there's this implied 1 right here. W to the 1st power is w. If we had w to the 0 power, that would be 1, not w. So we want to take 3 w to the 3rd and w to the 1st power. And we're ignoring all of this other stuff. We're ignoring everything else except for the w's right here. So when we have division, there was a property that we had. There was a property that we showed in class. We discovered this in class, where if I expand this out, w times w times w, and divide by w, one of the w's will cancel, and then I'll be left with w squared. What I can do as a shortcut is w to the 3rd power over w to the 1st power. I subtract the exponents. This is w to the 2nd power. 3 minus 1 is 2. now I have x to the fourth over x to the fourth. I can do the same thing. I subtract the exponents. So on this one, I'm going to have x to the 0 power. I have x to the 0 power. And we'll deal with this later. I just want to make sure I get everything down. There's nothing wrong with writing an extra step. Sometimes it's actually helpful, so that way if I try and do too much at once, I tend to lose some stuff. Human beings are very bad at doing multiple things at the same time. So I'm going to just leave it like this for now. I can come back to it later. Y to the negative second over y to the second power. Now, be very careful here. This is not 0 and it's not 4. What I can do as a middle step, I could actually write it right here. I can write negative 2, and then I'm subtracting 2. This is going to give us a negative 4. If I can just see it, I can write a negative 4. Or what I could do if I'm using scratch paper is I can do y to the negative second minus 2, and then I can just write a negative 4 over here when I evaluate this. And then on the last one, z to the negative 8th over z to the 12th. What I do is I subtract those, and again I can go over here to my scratch paper, or I can do a middle step, and I get z to the negative 8 minus 12, and that gives me z to the negative 20th. Now, in some classes this would be a perfectly acceptable answer, but we're not just training you for this class. We're not just looking for one possible solution. We want to represent this without negative exponents. That's the expectation in this class. So, and we also want to eliminate all these extra multiplications by 1, because this multiplication by 1 doesn't do anything. If I do 1 times anything, it stays like it is. So what I'm going to do is I'm going to rewrite this, and I'm going to rewrite it without using any negative exponents, and I'm going to rewrite it without using these factors of 1 here. So if I multiply by 1, that doesn't do anything. I'm just going to omit that. And what I'm going to do is I'm going to deal with the top row, and then I'll deal with the bottom row. So w to the second power is going to be w squared. X to the 0 power, that's 1, as long as x is not 0. If x were 0, we'd have division by 0 already, so we don't need to worry about that. So here we have 1. If I multiply by 1, it doesn't do anything. I can omit that. And then I have y to the negative 4th power. Now what I do with this as a shortcut, remember that y to the negative 4th power is just 1 over y to the 4th power. So basically it was in the numerator as a negative exponent. It's going to be in the denominator as a positive exponent. It was in the upstairs. This is over 1. Now it's going to be in the downstairs. So I have y to the 4th power. And yeah, there's that 3 there, but again, I'm going across the top, and then I'm going to go across the bottom so I don't lose anything. Z to the negative 20th, I can simplify that as z to the 20th power. And again, this is upstairs with a negative exponent. It'll go downstairs with a positive exponent. And then I have this 3. This 3 is going to stay on the bottom. So I can clean it up a little bit. There's nothing wrong with how this is written. I would take that. That's completely right. W squared, I'm just going to center it. 3, I'm going to write this legibly to the 4th power. Z to the 20th power. This is what I'm looking for on this one. So no, again, in some circles this would be okay, but we're writing this without any negative exponents and making sure that we put it in the correct location on the long fraction bar. Notice that the first thing we did in every case was we drew the long fraction bar. This helps to focus us on what we're supposed to do. And simplifying this exponent, I can rewrite this as, again using the commutative property and the associative property, I can write these in any order that I want. This is all multiplication, 3 times x squared times 5 times y times 12 times x to the 9th. This is x squared. Let me group all my x's together too while I'm at it. There's nothing wrong with that. And then I have a y here. 3 times 5 times 12. That's going to be, should work this out ahead of time, 60, 180. 180, x to the, and then I add exponents when I get here, x to the 11th, and then this y I can't combine because it doesn't have the same base as the x, so I'm done. 180 x to the 11th times y. If you're having trouble with these, look in the book at the last few homeworks that we did in the section before the quiz.